Hi everyone, and thank you for joining this webinar. Today's goal is to give you the complete guide to analyzing Net Promoter Score, or NPS. I'll go over the basics, so if you haven't analyzed NPS before, you'll get a lot of good ideas. But as the webinar title suggests, this is the complete guide, so I'll also cover more advanced topics. I'm presenting using Displayr, but everything can also be done in Q. If you have any questions, please type them into the questions field in GoToWebinar, and I'll go through as many questions at the end as possible. If you don't have Displayr and want to learn more about it, you can book a demo using the web address shown here. I'll start by looking at the two ways of calculating NPS and why some people love and others hate NPS. Then I'll get into the fundamentals of turning NPS data into strategic value. It all starts with a simple question. How likely are you to recommend something to colleagues or friends? People are given 11 options, ranging from 0, which is not at all likely, to 10, which is extremely likely. Often, there will be follow-up questions as well, asking people why they said what they said. We then tabulate what percentage of people chose each of the 11 options. If people chose a 9 or 10, they're considered promoters. These people are most likely to promote the brand or product to colleagues or friends. The theory is the more promoters, the more referrals, and the higher your sales. You can see 50.6% of people are promoters in this study. Now, if people chose a score in the 0 to 6 range, they're considered detractors. 16.4% of people in this study are detractors. So while 50.6% of people will say nice things about the brand, this is offset by the 16.4% who will say bad things. The difference between these two percentages is the net level of promotion, or the Net Promoter Score, which again is often referred to simply as NPS. The NPS for this study is 34.2. Now sometimes NPS is presented as a percentage, that is 34.2%. Other times it's just a number, 34.2. In practice, experienced market researchers don't calculate NPS this way. Instead, experienced market researchers recode the likelihood question. Let me explain. Here are the percentages again. We'll start by computing the average rating from 0 to 10. So the average rating is 8.2. When we compute the average, it's the average of these values that you see here, weighted by the number of people that chose each value. And the trick is to change or recode these values, assigning a value of -100 to the detractor categories, 0 to the passive categories, and +100 to the promoter categories. I'll go ahead and do that recode. And you can see, once I do that recode, the average is now 34.2. So we're getting the same answer with this different approach. And the nice thing is, you don't even need to recode manually like I just did. If you just click on a likelihood to recommend variable, you can then just click Displayr's automatic NPS recode. And doing so will create a new variable for you automatically, and I'll go ahead and rename that variable. As you can see, this is very fast and easy. And as I'll soon show, this alternative way is also much smarter. But let's take a slight diversion and discuss the history of NPS. Our CEO here at Displayr used to hate NPS, but now he loves it. And he wasn't alone. A lot of market researchers hate NPS. It's pretty common for people to give a low rating and then follow up by saying that they'll always give a low rating if you use NPS. And the reason they hate NPS is that many of the claims made about it aren't really true. There's a lot of snake oil selling going on. The first big aspect of this relates to the cutoffs. Why 9 or 10 for promoters, but not 8? The cutoffs are pretty arbitrary, and there's a lot of evidence for this. For example, Europeans are just less likely to give 9s and 10s than Americans. Also, the link between these ratings and whether people actually give recommendations isn't strong. And lastly, promoting is a behavior, but the question asks about intention, so there's a bit of a disconnect there. Now, according to the Harvard Business Review paper that first promoted NPS, it's the best predictor of growth. But there doesn't seem to be any serious evidence that supports this claim. And another weakness is that the calculation ignores a lot of information. For example, someone who gives a 6 is obviously very different than someone who gives a 0, but NPS ignores this. And the last common complaint is that before NPS, market researchers used average customer satisfaction, and it mostly did the same thing. There's no published data suggesting NPS is better, and many market researchers got pretty irritated when all their old data was tossed aside in favor of this bright and shiny new thing called NPS. All that said, NPS has long since triumphed and became the standard. And there's 6 reasons for that. First, it's simple. Anybody can use it and understand it. It's certainly easier to explain than average customer satisfaction. When explaining customer satisfaction, you had all these weird conversations, such as why is the top category a 5? Second, NPS is short. You can ask just the one question, or you can add a couple follow-ups about likes and dislikes if you want. This makes it practical to use. For example, when you take our NPS survey here at Displayr, our customer success and support teams read and analyze responses and then take corrective action if needed. This is only practical because NPS is short and simple. With a 20-minute survey, people would say all this great stuff, but those teams wouldn't have acted on individual responses, and the feedback loop would never close. NPS is also versatile. You can use it to compare brands, products, employee happiness, touchpoints, etc. And fourth, it's a concrete business outcome. A negative NPS implies more people are complaining about your business than promoting. An NPS increase should lead to an increase in sales, since people often buy based on recommendations. By contrast, customer satisfaction is neither concrete nor a business outcome. What exactly does satisfied mean? It's an abstract concept. For example, what's the commercial implication of a satisfaction score of 2.9? Or what's the commercial implication of a drop in satisfaction from 4.4 to 4.2? Is that meaningful? Who knows? NPS is simply easier to interpret. Also, when used sensibly, NPS is predictive. If somebody completes your survey gives a 0 and says your software stinks since it won't export to PowerPoint, you know you're in trouble if you don't fix that. Now, many market researchers can justifiably say that it's likely possible to create something even better than NPS, but you'd have a very difficult time getting it off the ground. Simply put, NPS is now the standard. It's locked in. You'll recall before I mentioned that NPS ignores a lot of information. This means it's quite volatile. It can be hard to determine when NPS differences are meaningful or not. Fortunately, this is an easy problem to solve. You just need to use stat testing. That is, Displayr's automatic stat testing will give you the correct results for comparing NPS results if you use the automatic NPS recode that I showed earlier. All we need to do is drag the NPS variable onto the page to create a summary table. And then just add other variables like age to the columns of the summary table to change it to a crosstab. As you can see, NPS is lower for 18 to 24-year-olds, and the red font and downward arrow tells us the difference is statistically significant. So we'd say 18 to 24-year-olds have a significantly lower NPS based on this crosstab, but the other differences aren't significant. Most of the big NPS missteps we see here at Displayr relate to looking at NPS over time. I'll create another crosstab, but this time we'll cross NPS by week. By default, the stat testing here says that the NPS in week 2 is significantly lower. If we want to stat test adjacent weeks, however, we need to instead change our stat testing options. So the significant changes week over week are the ones from week 1 to week 2 and week 2 to week 3. But this type of stat testing in general that compares data over time isn't great, as the confidence interval, such as whether it's 90% or 95% confidence, becomes very important. And things change based on whether you use weekly, monthly, or some other time period. There's a better approach, and that's using something called a spline. The black line shows our best estimate based on all the data. Note that it's showing much less fluctuation than the raw data. The black line is always between 32 and 38. And the pink shows our uncertainty. It's basically telling us that the uncertainty is much greater than the movement as a whole. So we don't have enough evidence to conclude that NPS is changing over time. The best way of benchmarking against competitors is to do a survey, like this one here that asks NPS for people's main cell phone company. We quickly see here that AT&T has a problematic NPS that's significantly lower. But there are lots of situations where it's not commercially practical to collect high-quality NPS data for competitors. For example, we can easily ask our customers' NPS, but getting a list of competitors' customers and asking them NPS really isn't feasible. Let's say our NPS for the current quarter is 64. How do we evaluate that without surveying competitors' customers? This is what makes NPS so good. In the old days, a client would say their customer satisfaction score is 3.8 and ask if that's good. The answer would be kind of or not sure. Fortunately today, enough companies do NPS surveys that it's easy to get a good idea what to expect and what's good. Here's some 2021 data from Satmetrics, who are the originators of NPS along with Bain. I can look at our score of 64 and quickly say that we're well above most industries, which is great. And remember, the average NPS for our cell phone study is 34. You can look at this chart and quickly see that that's very consistent with the published benchmark for cell phone service. And if you hunt around, you can find even better data. Displayr is technically a software as a service or SaaS company for short. The average NPS for SaaS companies is 40, so we're well above average. It is worth noting, however, that NPS is easy to manipulate. You want your NPS and any comparison NPS to be obtained from a representative cross-section of the brand's customers. And there are a few easy ways to deliberately or inadvertently inflate NPS scores. For example, one company used to get their staff to hand out NPS questionnaires to diners during meals and then collect them at the end. And no surprise, their NPS scores were more than 30 points above what they got from emails. Also, companies clean or remove people who give very low scores from their data, so that inflates it. And not sending survey reminders is also a problem, as it means that your lovers and haters, in other words, those with the strongest feelings, are more likely to respond. And failing to weight NPS data to address non-representative samples is also a problem. It can lead either to inflation or deflation. Weighting, which you can do in Displayr, is often necessary. And one way of deflating NPS is to get the data from non-customers and trialists. So if you're asking your customers to rate competitors, you're inadvertently making this mistake. So how do you work out if it's worth improving your NPS? While there's no perfect analysis, we recommend identifying a key commercial metric that you believe is causally linked to NPS. For example, here at Displayr, we believe that customers with low NPS are more likely to churn or not renew. You then bucket customers based on the commercial metric. For example, bucket 1 for us is customers that churn, and bucket 2 is customers that renew. You then calculate the average commercial value of customers in each bucket. For example, for bucket 1, again, customers that churn, the average commercial value is $0. And for bucket 2, customers that renew, the average value per customer is $5,000, and the expected future lifetime is 10 years. So the average value is $50,000. You then calculate NPS for each bucket. And with that information, we can discern that each NPS point improvement is worth approximately $3,000. And that's the $50,000 divided by the difference in the NPS for each bucket. An even more rigorous approach is to build a churn model where NPS is used as a predictor variable. This next approach is really cool. You form one segment of core customers. These are people who are in your target market or are your ideal customers. For example, our core customers here at Displayr are market researchers who work with quantitative survey data. The second segment is customers who aren't in your target market but have a high NPS. These are people you make happy without even trying, and they're a great opportunity for sales and marketing. The third segment is people you've sold to but are unhappy and aren't in your target market. These are the people you want to avoid, and it's really important that you do. You want to filter these guys out from any analysis of what people want, as they'll just skew all results. Now, let's shift gears and talk about data visualization. Gauge plots, like the one to the left here, work well, as they allow you to deal with negatives. It's clear scores range from -100 to +100. And spark lines, like the one to the right, work well for showing trends. Here's the same basic idea, but we use bars instead of gauges. We again emphasize the range from -100 to +100 and call out higher results with green. Here we use more traditional types of charts. But due to the tendency of people to overanalyze NPS data, we use little boxes to automatically highlight significant differences. For example, we see that 18 to 24 and 35 to 44 age groups have significantly different NPS results, but the gender difference isn't significant. Here's another example. Some NPS studies ask NPS by different touch points or stages in a customer's journey. For example, how likely would you be to recommend your supermarket's bakery to friends and family? Here, we're looking at NPS for different supermarket departments or sections. And the NPS are color-coded with a traffic light coloring system, where green is good, orange is okay, and red is poor. And since this is an interactive dashboard, we can use filters to focus on specific segments and stores. For example, I can go ahead and select the Aldi filter to focus on Aldi. Let's focus on this 16 for milk. How is that computed? We can just click on it to drill down. And the nested pie chart allows us to easily see the NPS breakdown. We see, for example, that 39% are promoters, and slightly more of them gave a 10 than a 9. Now, if you want to compare touch points across brands, a scatter plot like this can be very effective. We clearly see that Boost Mobile is first on a few touch points. And here, we just add black circles to highlight significant differences. This visualization here tells a lot of stories. It shows NPS by demographics and brand, and it allows us to quickly see the biggest outliers are young people and those of Hispanic or Latino origin. And the bubble sizes represent the percent of sample for each segment. It's often a good idea to collect open-ended text data. For example, it's common to ask why people gave their score. I don't like these as I find the resulting data is pretty ambiguous. Let's say somebody gives you a rating of 8 and mentions price in the follow-up. What does that mean? Is your price good? Or are they saying they would have given you a 10 if your price was lower? There's no way to know. And for this reason, I like to instead ask people what they like and what they dislike. These are the reasons why people said they dislike their cell phone company. The next step is to categorize or code this text data. And with AI advancements, Displayr makes it a lot easier and faster to accurately code text data. and I strongly recommend checking out our CEO's recent webinar on this topic if you haven't already. I'll go ahead and quickly code these dislikes. We can create categories or themes manually. For example, we see 512 people said nothing. I'll tackle those people manually. Or we can use AI to create themes for us automatically. I'll use AI to create an additional 4 themes. We can then automatically classify responses into the existing themes using AI. There we go. You can see we've classified 99% of the responses. I'll go ahead and just quickly add an other category to capture the rest. And then we just save the categorization so we can analyze it. And we can start the analysis by just creating a basic summary table. And the next step is to see how this data relates to other data, like demographics or brand. For example, let's change this summary table to a crosstab with age in the columns. There we go. And we can see that price is less of an issue for the youngest age group. And customer support or customer experience is more of an issue for those who are 55 to 64 years old. One visualization that's particularly helpful is a mosaic or Mecco plot of the categorized text data by the original 11-point likelihood to recommend data. You can see interesting correlations, with one category being more strongly associated with higher promotion or recommendation levels than others. For example, in this visualization here, it's clear that saying there's nothing they dislike with their main cell phone companies is associated or correlated with higher levels of recommendation levels. If a survey is longer, it'll often collect additional data that's thought to drive a higher NPS. Typically, these will be ratings for various touch points, aspects of the customer journey, or customer support attributes. This additional data is often NPS data or satisfaction or customer effort ratings data. For example, here's NPS data for different attributes related to cell phone companies. The key question is how important are these in terms of predicting overall NPS? This is known as relative importance analysis or driver analysis more commonly. And driver analysis is easy to perform in Displayr and Q. This driver analysis tells us that network coverage is the most important driver of NPS, followed by internet speed. And the orange boxes are warnings. Displayr's built-in expertise is making sure we set up the driver analysis properly. For example, the second orange warning suggests we use robust standard errors, so I'll do that. And if you want to know more about these orange warnings and more detail about driver analysis, You can also check out our driver analysis webinar and ebook. Quad maps are powerful visualizations that plot performance or satisfaction data by importance data from driver analysis. I plot importance on the x-axis and performance on the y. And I'll quickly make some formatting changes, such as adding titles to the axes. And what's really cool is you can have Displayr automatically create the quadrants for you. There we go. This quad map here shows the results for the total market, but we can also filter by brand. Looking at just AT&T, we see it's actually doing a good job. In other words, it performs well on the most important things, which are, again, our network coverage and internet speed. By contrast, Boost Mobile performs poorly on the most important things. And that's the complete guide to analyzing NPS. Friendly reminder that if you don't have Displayr and want to learn more about it, you can book a demo using the web address shown here. Now, let's move on to your questions and answer as many of them as possible in the remaining time. Just give me a few seconds to switch gears and review the questions. And I don't see any questions yet. So just again, want to see if anyone has any questions. I'm happy to answer. Just again, enter the questions in the questions field and go to webinar. Last call for questions. Okay, we got one. So, someone's asking that when you apply the significance testing, are you testing the final score or the proportions underneath? Also, which sig test is applied? Yeah, good question. Let's go back to comparing results. Yeah, so we are right here. We're comparing the averages that you see here. And you can always, the nice thing about Displayr is you can always see exactly what's going on with the stat testing by selecting a cell with a significant difference and then selecting the statistical test option. And then that's going to tell you exactly what type of test is being applied. And you can see that it's comparing the average of those who aren't 18 to 24 to those that are. And the null hypothesis is there's no difference, but we're rejecting that at 95% confidence or significance. So there is a significant difference, hence the red font and the downward pointing arrow. Oh, we got another question about sig testing. Okay, so this relates to comparing results and performing significance testing over time, like we see here. Okay, so let me show you how we started. All right, Displayr's default significance testing is going to compare data to the rest of data. Okay, so I'll go ahead and apply that selection. Okay, so now what this is telling us with Displayr's default stat testing is that this 24.4 for week 2 is significantly lower than all the other weeks. Okay, but what I did is I changed the stat testing. So when you use time periods to compare results in Displayr, you can do a specific type of stat testing where you're comparing each time period to the previous period. Okay, so this is the change I made. And I'll go ahead and apply it to the crosstab. So now, instead of comparing each week to the net of the other weeks, we're comparing week 2 just to week 1, week 3 just to week 2, and week 4 just to week 3. So now we're just stat testing the week-to-week change. And yep, a follow-up question was, is this option testing against the previous time period available in Cube? And it is. Okay. Well, we don't have any more questions, so we'll call it a wrap. And thank you everyone for joining, and take care.